This lesson is about completing the square to solve quadratic equations. So that's our objective, is to solve equations using completing the squares. What we're going to use is the pattern for quadratics of how to use those patterns when they involve perfect squares. So as an example here, we have that x plus p, the quantity squared, equals this pattern. What I want to emphasize is how that 2 shows up in the middle. Let's take a look at an example. If we had x plus 11, the quantity squared, that means you write it out twice, and then what you do is you double distribute, so x times x is x squared, x times 11 is 11x, x times 11 is another 11x, and then 11 times 11 is 121. So notice we have 2 11x factors in the middle, or terms in the middle that we add together, and so we end up with x squared plus 22x plus 121. It ends up being double what that number is there. So we want to use this idea and pattern to solve. So let me just remind you though of a couple things before we do these problems down here. Using the space over here, if we have x squared equal to, let's say 25, or excuse me, equal to 36 as part of this problem, if I want to take the square root, this is saying what squared equals 36? Well, both 6 and negative 6 squared equals that 36. So what you should recognize is that when you take the square root of 36, you get just 6 when we take the square root of both sides. But when I take the square root of x squared over here, technically it gives me the absolute value of x because it can be both a positive and a negative, and that gives me 2 answers, x equals 6 and x equals negative 6. And because of that, we oftentimes just go straight from here, take the square root of both sides and say x equals plus or minus 6. So we go straight past the absolute value step, but that's where the plus or minus comes from. So let's go ahead and do that over here with these problems. Let's solve these, and then we'll come back and do some completing the square. So on this one, we want to get rid of the square. We use the same pattern. We take the square root of both sides. On this side, the square root of 25 is 5. The square root of this side is the absolute value of x minus 3. But just to save us time, we're going to skip straight to the plus or minus. X minus 3 equals plus or minus 5 because of that absolute value step. Now we have 2 cases. X minus 3 equals 5 and x minus 3 equals negative 5. So we get x equal to 8 and x equal to negative 2 when we add 3 to both sides. So 2 answers that work in this original. Now, what if we have a problem like this? This is a perfect square. Notice that the square root of 81 is 9, and if you double it, you get that 18. It's this pattern we have up here, where if you take the square root of this one and double it, you get the middle term. So this factors into, if we were to write out the in-between step, x plus 9 and x plus 9, which is the same as x plus 9, the quantity squared. Now we can do like we did up here, take the square root of both sides, skip past the absolute value step, and just make it x plus 9 equals plus or minus, let's erase that, equals plus or minus the square root of 7. Now we go ahead and subtract 9 on both sides, and we get x equals negative 9 plus or minus the square root of 7. Those are 2 answers, negative 9 plus the square root of 7 and negative 9 minus the square root of 7. So what we want to do is be able to take advantage of the fact that perfect squares we can solve by doing the square root of both sides. But what happens if we have a problem that the term we have here is not a perfect square? So let me give you some steps of how to create a perfect square out of this and then to solve the equation. So the first step we want to do is we want to first of all get the constant on the other side. Okay, so we bring it over to the right side. Now the next one, which we don't have here, is if there is an a, when we refer to these, we think of our general form of ax squared plus bx plus c equals 0 for the general form of a quadratic. If there's an a, divide by a. Okay, and make sure you divide every term by a when you do that. Okay, the next step is you take half the x coefficient square it and add it to both sides. And then once you've done that, you solve. Okay, let me show you what I mean by that. So let's follow our steps. First step is to get the 3 on the other side. So I'm going to have x squared plus 12x, and I'm going to have a negative 3 on this side. Now what I like to do, there's no a in front here. It's implied to be a 1, so dividing by 1 doesn't change it. So step 2 doesn't apply here. But the next step is we're going to add to both sides. I like to put a blank on both sides. I'm going to take half of this 12 and square it and add it to both sides. Half of 12 is 6. 6 squared is 36. And I add that to both sides here. This one here, when I look at it, I've got that pattern that I noticed that if I take the square root of that 36 and double it, I get that 12. That's the reason for you take half of it, because it ends up being, in the final result from the perfect square, it's been doubled. So what I get on this side is x plus 6 times x plus 6 equals that positive 33, which ends up being x plus 6 squared. Now you can just skip to this step if you want to, skip past this one if you start recognizing that that's your perfect square. Now take the square root of both sides. So we're going to solve by taking the square root of both sides. We skip the absolute value step by putting the plus or minus on the other side. And then we're going to subtract 6 from both sides. X equals negative 6 plus or minus the square root of 33. You can leave it like this if you want to. This tells you the 2 answers to it. Or if you want to list both answers, you get negative 6 plus the square root of 33, and you get negative 6 minus the square root of 33 is your other answer. So those are the 2 ways that we could write that final answer. Let me do one last equation for you. So I'm going to erase this over here. Let's try one that has an a in the front. So what I'm going to have is I'm going to have 2x squared plus 8x plus 5 equals 0. Okay, so let's try this one. What I'm going to do first of all is I'm going to subtract 5 from both sides. So 2x squared. Actually, I'm going to make this an even number just to help me. So instead of 5, I'm going to make it 50. Okay? All right, this will also involve our complex numbers, our imaginary numbers. So 2x squared plus 8x equals negative 50. Now what we do is we're going to go ahead and take and divide every term by 2. So I'm going to have an x squared plus 4x plus blank equals, this also has to get divided by 2, so equals negative 25 plus blank. Now I take half of this middle term, x term coefficient, it's called the linear term, and square it. Half of it's 2, squared is equal to 4, and add that to both sides. Now notice here with this 4, that 4, take the square root of it and double it, you get that middle term. And that ends up being x plus 2, the quantity squared, equals, this is negative 21. Take the square root of both sides, you get x plus 2 equals plus or minus the square root of negative 21. When we have a negative underneath the square root, we take the I out. We're going to subtract 2 from both sides, so negative 2 plus or minus I square roots of 21 is our answer for that one. So to solve quadratics using the completing the square pattern, this is the perfect square pattern. Here's our steps where you go ahead and you set it up so that we can use that pattern to take the square root of both sides to solve our equations.